In this video, we're looking at the exponential regression problem here. And so I want to show you how I do this in Desmos. So the table is number 3 from 4.8 for Math 126, and it's probably a similar number. It might be a similar problem that shows up in 124. So the table shows the population of a fictional California gold rush town named Lehigh in the years after its peak population in 1880. So we're showing 1880 is the first year, and 1890, 1900, 1910, 1920, 1930. And then it shows the population declining. And then for the purpose of this problem, let P represent the population of Lehigh T years after 1880. So T equals 0 is 1880. So we'll be using 0 as our initial year, then 10, 20, 30, 40, 50. So use your calculator to determine, we'll use Desmos, determine an exponential regression equation that models the set of data. Round the A value to 2 decimal places and round the B value to 3 decimal places. Use the indicated variables and the proper function notation. Okay, so I'm going to come over here and grab my Desmos. Let's bring it in. And I probably need to, make sure I'm within the boundaries. Okay, so let's look at, I want to do a table. So I guess you can't see this. Let me see if I move this over here. Okay, you can see this now. See the little plus button here. I'm going to go to table and I'll put the values in. So we have 0, and then it goes by tens, 10, 20, 30, 40, and 50. And then our population starts out at 8,100. Then it goes to 4,200. It cuts in half. Wow. Then it goes to 3,580. And then it goes to 2,927. 1,582. And finally 894. Okay, now nothing's showing up here because my window isn't quite right, so let me change. I'm going to slide this over again so you can see we're making some changes on the graph. So over here on the graph, I'm going to do my x-axis. Let's just say like maybe -1 up to, I'm going to say maybe even -10 up to 60, just to give some buffer so not everything's right at the edge. And then the y-axis, let's see, we'll go from -20 up to 8,200. And you can see those values. In fact, I'm going to take and maybe make this -200, maybe -500. There, that gives me a little bit better picture. And I think you're starting to see, let me drag this down a little bit so you can kind of see the graph of what's happening. So let me just confirm these. 0, 8,100, 10, 4,200, 20, 3,580, 30, 2,927, 40, 1,582, and 5,894. Okay, so now we go to this next. Let me change this window again a little bit. If I could drag it to make the whole thing bigger. Although this might be enough, yeah, because we're still seeing it. Okay, I think you can see the relative points, and you can see the data here. So I'm going to see how it says y1 there and x1 there. I say y1, it automatically does the subscript. And then I do shift tilde. Now the tilde button on my keyboard is to the left of the number 1 button. I hit shift. If I don't hit shift, I get this kind of kind of like an apostrophe. So y1 tilde, and then I'm going to do a b to the power x1. And it comes up with an equation. This doesn't seem, well, that's what it is. This does not seem like it fits very well. And I'm seeing the 7706.502. Now, I'm not sure what they're using because they came up with 7751.44 times point, but this is the same 0.96. So that makes me wonder, is there an issue with my data input? But I just double checked it. And answering the rest of these is going to be based off of it's going to be based off the, oh, there's that first data point way up here. Okay. Based off this formula, so there's going to be propagated error given that the A is off comparatively, 7706 versus 7751, there is a difference. So I'm wondering if they used a TI. I bet they used a TI-84 for their value. Okay. So let me come back over to this problem. I'm going to drag this away. And what we had come up with. So if you have this problem, I'm happy to give you credit. I'll give you I can always override the score. Okay, so what we came up with is y equals 7706.502 times, I know it says around at two places, but whatever, 0.960484 to the x power, or I guess to the t power. Okay, so it says based on your regression model, what is the percent decrease per year? And so that's going to be based on this part in the base here. So if we're looking at 100 minus 96, so it's 4%. The next question, which is going to drop us to the next page, says what is the population at 25 years? Because we have it at 20 and we have it at 30. So what we'd be looking at, the population at 25 years, it's going to be the 7706.502 times 0.960484 to the 25 power. So I'm going to grab my TI calculator for this. Let's see what we come up with. What we could also do, let me just do this. We have the graph. Let me drag that back if I can find wherever I dragged it. There it is. Drag this back. And we can look and see, okay, at 25, let's just do this. Let's type in x equals 25. And that'll tell us, that'll give us a value here. In 25 years, it's at 2812.64. So if you want to round to 2813, you could do that. And that's going to be a little different than the program's answer because they had 2794, again, based off of a different value up here. Okay, so what did we come up with? 2812 is my answer. So interpret your answer by completing the following sentence. Be sure to use units in your answer. The population of Lehigh, 25 years after 1880 was about 28, I should say 13. Let's call it 13, we round up people. How long did it take for the population to reach 460 people. So I'm going to come back over here, and I'm going to do another one. I'm going to say y equals 460. So y equals 460. And I'm going to have to drag this graph over a little bit. And look at that. After it looks like about 70 years, you're at 460 people. The computer's answer said 69 years. But anyway, this is how ours works out. So I say 70 years. Interpret your answer by completing the following sentence. In how many years? 70 years. After 1880, the population was about 460 people. How long will it take the population to drop by half? Well, that we saw in the data itself. That's not quite, no, because it went from 81 to 42. Could that have been a mistake of mine? Could that have been a problem changer? Let me get back to my graph, wherever that went away. There it is. No, that was what we had. So half of 8100, that would be when y equals 4050. So 4050. Okay. So that would be 15.95 or 16 years. So it took 16 years to get down to that population. There we go. Let's see what they said in the answer key. They said 17. Yeah, slightly different graphs. Interpret your answer by completing the following sentence. In 16 years after 18, the population dropped by half. So that's how I do this problem. And I just accept that there's a little bit different ways these two programs will calculate things. So they're generating slightly different problems, formulas. So if you need me to look at it and give you credit, I'm happy to do that. So, okay, hope that helps.